on the distributive property in the unit expressions and equations. So we're going to begin by defining a few terms. All right, the definition of terms are parts of an expression separated by addition, subtraction, or multiplication and division. So in the example, 3x minus 7y plus 2x minus 1 has 4 terms. 1, 2, 3, 4. And they are, so 3x is one term, negative 7y, 2x, and negative 1. The definition of a coefficient is the number multiplying the variable. So if I have 3x, the coefficient is 3. This number right in front of the variable. Constants. Numbers. They remain the same. They cannot have a variable. So if I want to identify the constant in this expression, the one without a variable is 5. Like terms. Terms that have the same exact variable and exponent. So if I ask you to combine like terms, you're going to take terms with the same variable, and this is 3x to the first power and 2x to the first power. And so that will give us 5x. Decide if each pair of terms is like terms, yes or no. So each x, and they're raised to the first power. So this is a yes. Here you have y and y squared, so they don't have the same exponent. That's a no. And then these do not have the same exact variable, so that's a no. So combine like terms. Add, when you combine, you either add or subtract the coefficients and keep the variable the same. Okay. So now we're going to practice combining like terms. 5x plus 3x is 8x. I suggest circling it and taking the sign in front of it. So essentially this is 7y plus a negative 3y, which is 4y. Then here, all right, same variable squared, same exponent. Circle, taking the sign in front, 7x squared. Then you have negative 10a. Again, taking the sign in front of it, that would give you negative 3a. Here we have x and x. So 4x and 3x is 7x. And then we have negative 5y and 2y, which is a negative 3y. Again, you want to circle them. Same exponent, same power. So this technically is 2z plus 1z, which is 3z. Now we're going to approach the distributive property in several ways. We're going to look at it algebraically, and we're going to look at it visually using manipulatives. So to apply the distributive property, multiply everything on the inside by the expression on the outside. Okay. So we're going to multiply the 2. So 2x plus 8. They're going to multiply the negative 3. Negative 3x minus 15. Same thing here. 4 is on the outside, and you multiply it. So 8x plus 28. Negative 5 times 4, negative 20x. And a negative times a negative is a positive, so that's a positive 10. Then you're going to take this 5. This is the commutative property. It doesn't matter which side. it's on, that is 5 times x, and 5 times 2, which is 10. Then, this is what I call invisible math, because you can't see the 1, but technically there's a 1 here. So this is negative 1 times x, and then negative 1 times a negative 3, which is a positive 3. All right. There we go. Okay, let's approach the next set of problems. All right, here's we're talking about the visual, all right? So we're going to use algebra tiles. So the distributive property is really multiplication. This means 3 times 2x plus 1, or 3 groups of 2x plus 1. Which are displayed with the algebra tiles, right? There's 1 group of 2x plus 1, 2 groups of 2x plus 1, 3 groups of 2x plus 1. Then, after you distribute, and it's sort of like combining like terms, you put all the x values together. So 2, 4, 6, that gives you 6x plus 3. So same thing here, right? This is 2 times that. It's 2 groups of x plus 5. That's how it looks right here. And then when we combine like terms, like you could literally add x plus x is 2x, and 5 plus 5 is 10. It's right here. So now we're going to draw a couple of examples. So 4, cheapest, times 3x plus 2. All right. So we're going to have 4 groups. You know what I'm actually going to do? And you can do this too. I'm actually going to do just red lines, just to make life a little easier and fit into this little space. Here we go. So let's see. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then 2, 1, 2, 1, 2. When you use dots, 1, 2, 1, 2. So that's before distributing it. I have 4 groups of 3x plus 2. Now when I combine them, I'm going to have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then I'm going to combine 1, 2, 3, 4, 5, 6, 7, 8. All right, so algebraically, that's 12x plus 8. All right, now let's distribute first. This is 6 plus 3x plus 5x. Now we're going to combine like terms, 3x and 5x. So we have 6 plus 8x. Okay, so you need to distribute first and then combine like terms. Really, you just want to be really careful of any negative signs. All right, so this is 4 plus 24 plus 16x. So that's 28 plus 16x. Now I want you to do 25 and 26 on your own, and then I'll check those on Monday when I check your notes. All right, so the distributive property is multiplication, but we're also going to use it to divide. All right, last year you began a little bit of factoring, okay? So what we're going to do for the top here is factor out a common factor, which is 12. So 3x minus 2. And then you have 6. So again, this means 12 times 3x minus 2. So I can simplify this by dividing 12 by 6, which is 2. So my final answer will be 2, 3x minus 2. Is there a way to simplify the expression without having to rewrite it as multiplication? Yes, and we call it the bean method. So several methods to do the same thing. So you can, right, circle that, it looks like a little jelly bean, and you divide these. So I could reduce that. So 4 is their common factor. So that's 10x. And then, oops, actually, sorry. 8 is obviously the common factor. And it's not letting me erase totally. Oh, it's kind of funny. All right, so I'm just gonna put a line through that. Sorry about that. So that's 8, so that's 5x, right? Plus 4. Because then I'm gonna use the other side of the bean right there. Okay, so this bean I'm gonna divide. It's gonna give me 2x. And then 8 divided by 2 is 4. A couple of different methods. Now here, just be careful, right? The first bean, so that's going to be negative 2y. And then the second bean, so it'll be plus 6. 18 divided by 3 is 6. I should clearly. That's the first answer. Second answer. Okay. Now the last bean method, we're going to divide a negative 10 divided by a negative 5, 2z, and then 20 divided by negative 5 is negative 4. Alrighty. And if you still have any questions, I would write them at the end of your notes, and then on Monday we can get to them. All right. Thank you. Have a good day.